What do we mean by that? Okay? We want to estimate the population mean using large sample size. So we said, and you said it yourself, when you have a sample size that is greater than 30, we are going to use the sample distributions of mean will be approximately normal. So our Z will always be, our standard normal Z will always be like this. Okay? This is the calculation for our standard normal Z, isn't it? So if that is it, if we want to calculate the population mean, which is this particular guy here, if we want to calculate, we'll just rearrange the whole thing. Rearrange the whole thing. Okay?
So this is the Z for the population, right?
Which one?
The Z is for the population.
Z is not for population, no. Z is standardized normal.
Yeah, for the sample for the population.
Standardized normal. For what?
The sample.
This is Z for the standardized normal distribution for sample distributions of the mean. That's why you have this square root over square root of n. If it's for population, this is what we are going to have. Sorry. If it's for population, you are going to have x minus mu over this. This is what you have. This is what I taught you. But we're not dealing with population anymore. I told you can't really work with population in reality. So what you'll be working with is going to be what? Sample. So this is what's going to happen in your sample. Okay? And this you are going to have it this way. Okay? Z for sample will be equals to x minus mu all over sigma over square root of n, because this is the Z, which is a standardized normal for sample. Okay? We did this last time now. Don't tell me you've forgotten this. Or am I rushing you?
No. No, not so.
Okay, so here mu, which is this is the population mean here. So if we arrange this, we'll have Z sigma over square root of n equals to x minus mu. If we take this mu to this side, take this guy to this side, we'll have mu is equals to x minus z over sigma over square root of n. So this is the population mean. This is the population mean. This mu here is the population mean. The only thing is this: Z in standardized normal has two signs. The Z in a standardized normal, if this is 0 now, if Z here is plus Z, it is the same value of Z here, which is minus Z. Please note that, because this is a symmetry. This is a symmetry. So the Z here, it has the same magnitude with the Z here. Is that okay? Okay, if this is one standard deviation, this is one standard deviation. If you have two standard deviations Z, so this is 2, it will be equal in value. So if that is it, that means this minus Z could also be written like this: mu will be x plus or minus Z. So because you can have any of the value over square root of n. So in trying to find, because this is the population mean, we can now spread it out. So in trying to find the population mean will be, let me put it here, the population mean will be x minus z sigma over square root of n less than equal to mean less than equal to x minus plus sigma over square root of sigma over square root of n. So this is how this will give us our estimate of the mean. This will give us our estimate of the population mean. This is how we can estimate the population mean from a sample. So if we have a sample and we know most of the parameters here, we know what the x is, we know what the sigma is, and we know what the sample size is, we can definitely find the mean, or we can have an approximate value of the mean of the population. Okay? Any question? Any question? Okay, let's go to a case study since there's no question. Let's look at a case study. Before we look at the case study, let me come back here. But let's look at the case study here. Then we will look at this case study. Okay? Then we will now use that case study to look at this. Okay? Now, when you hear the word confidence interval, most of the time is talking about the range at which the mean is situated. So for example, if you have something like this particular formula is the confidence interval of the population mean. That means the mean can go from this low tolerance to this high tolerance. So the range of the mean is between these values. Is that okay? It's the same thing is when we have a confidence interval. So I want you guys to look at this case study here. I'm going to use this case study to first of all find the confidence interval of the mean, of the population mean. Sheung, I want you to read this case study for me. I need you to read this case study for me.
Okay.
Read it out loud.
A survey was conducted of companies that use solar panels as a primary source of electricity. The question that was asked was this: how much of the electricity used in your company comes from the solar panels? A random sample of 55 responses produced the mean of 45 megawatts. Suppose the population standard deviation for this question is 15.5 megawatts. Find the 95% interval for the mean. Find the 95% confidence interval for the mean. Maybe pattern.
Okay, so did you get that? Who can interpret?
Then I can read. I read it.
Not read alone, no, interpret it to me. What do you understand by what you just read? What do you understand by what you just read?
Huh? Mu equals to.
No, just explain what you just read.
I don't know how to explain it.
So if you see something like this, you can't grasp it in God's of meaning. Yeah?
I'll just remove the element and try and work it back.
Explain it to me now in your own way. What you got to hear me? Jẹ́ kó yé mi. Kí ló yé nínú nǹkan tí tó wà nínú question yìí?
Well, from what they are telling me in this question is that x minus z into sigma over root n is equals to 0.95 plus or minus. And I can put in all the other this and work back to my
So it's what was that?
Nothing. We have not even done anything. I'm just asking Shehu to explain what this particular case study is. Anyway, Shehu, is it that when you try to learn, you don't learn by understanding this stuff? Huh? You learn by just calculating.
Okay.
Because that's what I
You said 95% confidence interval.
Yes.
What is x? What is x? And they have said that x minus z into sigma over root n is equal to 0.95 plus or minus. Are we?
Yes.
Sorry, that's how I understand it.
Ó ṣe yé ẹ nìyẹn àbí?
Can you get the answer?
No, it's not about just getting answer. It's about understanding, because if you go to the workplace and your fellow colleagues or fellow asking you what are we going to do and what does this mean, it's not just calculating now. You have to be able to explain to them what it is. Okay? So let's look at this together. A survey was conducted. What is a survey? What is a survey? Bolaji?
The way of okay.
Okay. No, just say. Is a way of what?
Taking sample. Is a way of sampling. Is a means of sampling. It's some form of sampling.
Baba, what's this guy's name? Bolaji? What's the meaning of service, Bolaji?
I was going to say the same answer. So, a way of collecting data.
Okay, it's a way of collecting data, not sample. There are two different things. But what kind of data does survey collect? Eh? Usually what?
Usually quantitative.
No. A survey is usually used for qualitative data anyway. Do you get? Are you there? Okay. A survey was conducted of companies that use solar panel as a primary source of electricity. A survey is like you are trying to get data. Most data you are trying to get from a survey is going to be a feedback. Okay? So you can see, and it's mostly used for qualitative data collection. Okay? Sometimes it uses what is called a Likert scale. It uses a Likert scale. For it. So it says, okay, 1 represents not good, while 5 represents very, very good. And maybe sometimes it graduates in ascending order like that. Anyway, so this question says the survey was conducted of companies that use solar panel as the primary source of electricity. This question they're talking about is the question on the survey. Okay, so the question that was asked was this: how much of electricity used in your company comes from solar panel? So a survey was conducted of companies that produce solar panels. So they went to each of the companies and asked how much of... Yeah, thank you, darling. So the question that was asked was this: how much of electricity used in your company comes from solar panel? How much of electricity? So that was the question on the survey. So people can fill any amount they want. But what happened was they took 55 companies, because a random sample of 55 responses. So that means 55 companies took part. But these 55 companies is not the whole solar, company that uses solar panel. 55 is just a sample of the companies that uses solar panel. And out of these 55 responses, a mean of 45 megawatts. That means 55 of them, by the time you calculated what 55 of them said, what they got was what? 45 megawatts. That means some people may have said 40 megawatts, while some people may have said 42 megawatts, some people may have said 50 megawatts, while some people may have said 45 megawatts. But by the time you add the 55 of it, only 45 megawatts was the mean of the 55 responses. Now, the question now asks, supposing the population standard deviation of this question is 15.5 megawatts. Supposing, this is just like a supposition. Supposing the population standard deviation for this question is 15.5 megawatts. Find the 95 confidence interval for the mean. Find the 95% confidence interval for the mean. That's the question. Find the 95% confidence interval for the mean. Okay? So now, what are we going to do? We want to find the 95% confidence interval for the mean. Okay, so I've tried my best to break it down and try to explain it as much as I can. So now the next thing is want to solve it. Oh, this thing is giving me a headache. So next thing is we want to solve it. 95% confidence interval for the mean. Okay. This is how we are going to solve it. Okay, so we know, please listen, that the 95% confidence interval is given this way. We already calculated this earlier on, that x minus, we already calculated it, minus z, this z, what's this z? That's the next thing. Sigma over square root of n is less than or equal to the mean, which is this mean, is less than or equal to the x plus z plus sigma over square root of n. This we already know is how to calculate confidence interval of the mean. We already know that if we want to calculate the confidence interval of the mean, this is what we'll get. Okay, so if we look at this, to calculate this, we already know that we want to find 95% confidence interval. We already know what the x is. We already know what the x is. Okay? We already know what the x is. Okay? Which is going to give us the x here will be the x bar actually, which will give us the 45 megawatts. Now the z here is what we don't know. Okay, then we know what sigma is, which is the 15.5, and we know what the sample size is, which is 55. So we have all the values we want. The only thing we don't have is this z, but they gave us a clue because they said we should find 95% confidence interval of the mean. So to find 95% confidence interval, this is how 95% confidence interval would look like. Here, then here will be 95%. This is what we call the 95% level. This 95% confidence level, and the interval will be from here to here. So if this is 95% confidence level, that means this tail will be 2.5%, and this tail will be 2.5%. Please note something. The opposite of confidence level, which is the 95%, is alpha. Alpha is the opposite. Alpha is, let me not say the opposite, let me say the how would I call it? I'm using a word, I'm looking for a word that will, opposite is also okay, but let me just say alpha is the opposite. Alpha is the opposite of confidence level. Opposite of confidence level. So what I'm trying to say in essence is that if someone tells you to try and get 90% confidence level of the mean, that means alpha will be 10. Alpha will be 10%. If someone tells you the confidence level is 80%, alpha will be 20%. So alpha is just like a complementary value to get 100% for confidence level. So here, we know that 2.5% is here, 2.5% is here. Now we can find z here, z minus z and plus z here, because that's what we are looking for. We are looking for this minus z here, we are looking for this plus z here. And we can find the minus z here, we can find the plus z here, giving um what do you call it, giving this value, giving this particular price 2.5 and give this portion is 2.5. We can find the z here, and we must find z here. We'll just take the z here and put here. We'll take the z here and put here, and that's all. And that's the story for today. Any question? Any question? Okay, please.
Does it mean that? Hello, sir.
Yeah.
Does it mean that we'll go and look for the probability distribution of minus 2.5 to get the value of z?
No, you already know how to get the value of z. Now you go to your z table and find the inverse, the norms inverse, the inverse of it. That means you go inside the table and try and track it down to the z. We did this now many times.
We use minus 2.5. We use 2.5 to find out the z. Abi?
You've used 2.5% to find out the z. 2.5% is the same thing as 0.05, 0.025.
Okay.
Do you get it now?
Let me just note it down.
Yeah. Oh yeah, solve. I'm not doing it for you. I do it. Then fill up this thing yourself and tell me your answer. I've done everything. I've done everything you need for life and godliness. I've done it for you.
Zero. Yeah.
Anybody has finished? Adedibo. Adedibo Baba Badon. Have you finished?
On that one, me.
Have you finished?
Yes.
What did you get?
40.90 less than or equal to mu
Okay.
less than or equal to 49.09.
Okay. Where's your 49 points?
09.
Okay. The statistics, so I'll give it to you. Kiloko Baboy. Kiloko Elga.
Sarumi. Keep Sarumi.
Sarumi.
I'm still working on.
Ah. Hurry up. I'm waiting for you. I'm waiting for you. Your friend has already found the confidence interval. And what can we say? The guy is shining. What he has found out. This is what you found out. You found out that the 95% confidence interval, right, is equal to the probability of 40.9 less than equal to mu less than equal to, it's actually supposed to be 49.1, but I will give it to you because it's statistics. Okay, this is what you found out, isn't it?
Yes, sir.
Congrats. What's the name of this boy? I will teach you, Tony.
I'm done now.
Huh?
I'm done now.
What did you get?
I got 60.87.
Okay.
Less than mu. Sorry. How do I interpret this thing again? Confidence level of between 60.87 and 49.1.
49.1 you got, but the 60.87 you failed. I'm sure you made a mistake in your calculation. Review it, but look at first the board first. You can review that one later. But you failed the first leg, the second one you got. Let's look at this. You go to start, basic start, one sample Z, because we are looking at one sample, and Z is because the large sample size, so the sample distributions of the mean is large. We go to summarize data. Our size is 55, and the mean of that size 55 is 45. 45 megawatts was found, and the standard deviation is 15.5. Now, hypothesized mean. The hypothesized mean is the population mean. This is what we are looking for. So we don't need to fill anything here because this is what we are looking for. So we click on option, and in clicking on option, the confidence level they asked us for is 95. So it's 95%, 95 confidence. If they tell us 90, we change it to 90. Is that okay? So we change this to this is what we are looking for, 95. And of course, the mean is equal to hypothesized mean. We click OK, and we click OK. And by the time we are through, we see that our value, this is our value, which is the same value at 95% confidence interval for mean, will give us 40.9 less than or equal to mean, or less than or equal to 49.1. Can you see that?
The mean, did you click the mean is not equal to hypothesized mean or what? What did you click there?
Where?
The mean.
No, the mean is not equal to the hypothesized mean. Yes.
That's what we clicked. Okay.
Yeah. Okay, so that's basically it. So that's how you find the what do you call it? That's how you find it. That's how you find the confidence interval for the mean. Okay? Any question? Any question? None. Okay. When people don't ask me question in class, it means they are very good.
No,
Isn't it?
okay, before you go, the last assignment you give us, the last part, is this something that is doable on the minute app?
No, not necessarily.
Okay.
Okay, another thing you need to know is this. You know, instead of you tracing those things that you were tracing when you were tracing on your table, there are some specific things they give you. You don't need to trace it anymore to find your Z alpha over 2. That part is called Z alpha over 2. This particular place, you know, when you do this, when you, sorry, what I'm trying to say is that when you draw your, this thing here, and whatever the interval they give you, the tail will be alpha over 2. So whatever alpha over 2 is, will be the equivalent of the Z alpha over 2. So this will be minus Z alpha, this will be plus Z alpha over 2. So you can use this and you can put it into the formula back. So this, you're supposed to know some of this so that you don't go back and start using your Z table in the exam. This will save you a lot of time. So for example, if you are given 95% confidence interval, you already know that alpha will be 0.05, because then to find the alpha over 2, because alpha over 2 will always be the tail end of the confidence interval, you can already know that Z alpha over 2 will be 1.96. Like for the last one you just did, your Z was 1.96, and it was this was minus 1. And this was plus 1.96. So you should know that. So they are the ones they always give you in exam will be either 90, 95, or 99 in terms of confidence interval of the mean. So you can use this to note the value instead of you going to Z table every time to be checking. So you should know this at the back of your finger. 1.96 is for 95% confidence interval for Z alpha over 2. For 90% confidence interval is 1.645, while for 99% confidence interval is 2.58. Are we okay?
Yes, sir.
Okay, so let's look at another one to study. Okay.
That's already there.
Let's try this one. Let's try this one.
So sorry, I'm hoping to ask Mr. something.
Okay, sir.
Okay, did you get the 40.9? Because I'm trying to understand how.
Yes. What I suggest you do is resolve what is in the bracket first and multiply it by 1.96 before you go and remove it from the 45. That's where the issue started from. Resolve the bracket first. Always resolve the brackets first before you now start the outside minus.
How did you get 1.96?
The Z from the Z table.
Z table, okay. Alright.
Yeah. 2.5 divided by 100. That's 0.025 minus 0.025. So that means you got to get the minus table.
Yeah, don't worry. No, I know where I went from.
Yeah, you guys solve this. Tumaloli. So for this confidence interval, I'm going to send you an assignment. A lot of assignment for you to do. Is that okay?
Mm-hmm.
So for this large sample size, I'll send you assignments for you guys to do. The one for CLT, the one that we did, do you want me to solve it for you? The last one. What? Do you want me to solve it for you? ọjọ́ tí mo jó lọ́nà o, kò máa tóbi rárá o. Kò máa tóbi rárá o. Please confirm with Minitab. Use Minitab to confirm. Use your Minitab to confirm.
When I do Minitab, the ever me, sorry, ó máa ń gbóná lọ lẹ́kọ̀ọ̀kan. Everything will just be white. So,
Everything will just be what?
white.
How?
The Minitab.
Did you update?
Used to break. No, update care. No.
I did though. I tried to update.
Did it affect you?
It did.
What
But
the-
now I'm using the trial version.
Oh shit. Next time, don't do that. Whenever you're in Lagos, let me know. Abi?
But it's like say you don't know a crack version they give us.
I don't know.
My you look for that.
Okay. I have an original version. My problem with the original version is in Minitab 17. It's a lower version than what you are using. I just wanted to. Normally, my students is 17. I give them. I don't know what happened to me. I now went to go and give you pull top of the chain version. But no problem. Maybe I should give you 17.
No, thank you. No, thank you so much, sir.
No,
You
no.
still come for the other one.
No. Coming for 17. 17 is 32 bits. It doesn't affect your 64. So what I mean, it doesn't affect your Minitab 19. You just like you have your 17. Your 17 is more stable, and it's what I'm trying to say is that the 17 is my own copy. It's my own original copy. It's more stable. It's not cracked. It's not anything. Do you get? But don't worry. This is the I've given you. You won't understand why this is a better version unless you use 17. You're not like, wow, it's like night and day, because the 17 is slower. You won't understand.
Sir, so there was something you were supposed to do that didn't show up.
What's that?
Yeah. The software for risk and for I think it's for Monte Carlo or something.
You don't have it?
No, I never made the last lecture, remember?
You did okay, you didn't do the last lecture. Why?
Something came up in the office, I can't remember.
Okay. What do you want me to do now?
I think one of these days I'll just stroll by to your office now and collect the. If there's something I can read up on it, okay. Then I'll now use it to follow the software. Because before I go meet my somewhere, before they carry the system for my phone, so yeah, go on.
No problem. If you just scratch my back with coins, I'll free allow you enter one of my classes.
Okay. I go scratch out with some paper.
Coins. I don't do sandpaper. I don't even do Bitcoin self. Now coins, real life coins. Now they do.
coin is lit.
Eh?
This coin is lit.
Which one?
This coin.
I know they do
That's the
Bitcoin.
future.
No, that's not a story. I know they do. Just give me cash
He's a
for
good person.
cash for hand, back for the hand. I know they do futuristic. I know they do futuristic anything. I want to see my money. I want to see my money.
Is there a standard number of decimal places that we use for this calculation? Because I see some level of inconsistency in the decimal places we use. Sometimes I see 3 decimal places, sometimes 1. Why?
Okay, just calculate. Are you true? Are you true? There's no. The most important thing is when being between your calculation, make sure you don't approximate. Always approximate at the end. Don't approximate in between. That's the most important thing. Are you true? Hello?
My answer is not the same as
Your Minitab. Minitab is the correct answer. I don't think you can even get Minitab wrong. Abi? Mr. Is it possible to get Minitab wrong?
Yes, sir.
That means your procedure is wrong now. It's hard to get Minitab wrong. Okay, do you want us to do it together?
yes, sir, please.
Okay, so let me do it from beginning to end because of Basarimo's sake. Abi? Basarimo seems to be messing this thing up. So let's sort it out, Basarimo. So Basarimo, look at this. Sarimo, look at this.
Sarumi.
Sorry.
Is it Sarumi?
Sarumi.
Okay, so
Chief Sarumi.
what they are asking for is 95% confidence interval of the mean. So here will be 95% confidence interval. Okay? And that means this will be 2.5. We've already done this before. That's 0.025, and this will be 0.025. And I've already told you if this is 0.0.5, this will be 1.96. I already know this because I just know it because I know that alpha over 2 for this will give me 1.96, 1.96. So there's no need for me to stress myself going to Z table. I already know it. Do you get it now? So once I know that, the next thing is I just need to fix it. X is what? X here is 7. Okay, the 7. Let's start with minus Z is 1.96. 1.96 multiplied by alpha, which is 2, all over square root of 200, less than or equal to mu, less than or equal to 7 plus 1.96 times 2. This one, once you just do the beauty of once you do this thing, this radical here, once you saw this radical here, all you just need is to either subtract or add to 7. That's all. So once you can get this, if you get your calculator out, always you did board mass in school now. Start with the square root of 200, like that, like that, like that, like that. By the time you are through, what would you get? By the time you are through, what would you get? Sheon, did you do it? Sheon?
Sir, sorry. Just to like I have to quickly.
This is what you get.
This
This is what you get by the time you are through. 6.7
sir?
less than equals to mu, less than equals to 7.2. Salma, is this what you got? Bola,
I didn't use 1.96. I used 2.84.
where you go get 2.9, 1.96? Maybe that means your Z table skills are still you still have challenges with your Z table skills. You need to go and brush it up. Shobo?
As in when I checked, so when I checked 0.025 and I did the reverse, it gave me minus 2.81.
What do you mean by reverse? because that word is not it's not a word that I hear often. Reverse. Please, let me show
What
you
you are
what.
looking for is already minus 1.96.
See, just come here, my oga. 0.025 is 0.025 under the curve is the same thing as 0.975. Is the same thing. 0.025 under the curve is the same thing as 0.975 under the curve. So you can just either you look for 0.025, that is 0.025, which is here. This is 0.025 here, which give you minus 1.96. Can you see that, Sarumo? Sarumi, sorry. Can you see that, Sarumi? So once you know that this is 1.96, this also you get the same thing if you go to Minitab. You go to Minitab to solve this. Start, basic stats, one sample Z. Here, the sample size is 200, I think. The sample mean is 7. Standard deviation is 2. Abby? 7. Standard deviation is 2. This is what you are looking for, the hypothesized mean. And 95, 95, okay. And you see that you get almost similar, the same thing that is this thing. So you guys will get a lot of assignments on this. So I mean, you need to brush up your Z table skills. You don't even have time to waste in the exam.
I see why I made the mistake. I was looking for 0.0025 instead of 0.025.
Okay. Please be careful. Okay. That's it for today. I will send you guys assignments. Okay. Is that okay?
I'm putting the recorded version for the lecture.
You need it?